So get them in your Y equals, change your window. Your T-step, maximum 10 seconds. Maximum, I would say, on a golf ball. 11 seconds, whatever. Your max for your X, it's got to be past the 275. I would like double it, just to see you're out there. And your Y max, how high does this golf ball go? Take a guess. 100 feet. Are these all feet, by the way? These are all feet. 100 feet maximum, for now. And let's graph it and see. So we graph it, we can see your parabola. If you need to adjust your window, adjust it. Your time is what's going here. This is your time. This is your X, your horizontal distance. If you watch golf, they have a drive of, 300 feet. It's from where they stand to where they drop the ball. God bless you. As the crow flies, right? How high, is the arc that they put on this thing. So your time now, if you want to get, what's it asking you? When will it hit the ground? Trace. Hit your trace button. There's your time. You're going to move this guy until you see Y hit 0. When Y hits the 0, you know you hit the ground. We're just above the ground at 4.8 seconds. We're below the ground at 5.1. So maybe I want to start my table at 4.9. You don't want to do your T-step in your window at 0.001. It goes way, way, way too slow. Use your table. Now you're looking to see when this Y hits the ground. When did I come out with the 0 here? Or the closest I can get. So see it right there? 4.885, I was above. 4.886, I was right below. So somewhere between 4.886 or 4.885, I am fine with that. Follow your distance. So say I choose this one. Scroll over here and round this to 3 decimal places. So we hit at a distance of 525.730 feet away from you. Horizontal distance. How high could this thing go? I could go back and look at my Y's before this. I don't think I asked you how high, right? Now, the second part of this said, will clear a 9-foot fence at a distance of 275 feet. Like when you play golf, maybe there's a tree in the way, or this one happens to be a fence. You have to make sure that your ball goes over it. Same thing with like the fence for a home run. You got to make sure that you go over the fence. So it is this distance, this horizontal distance that you're looking at, when that one is 275. Now, play with your table. You have 2 choices. You can start your trace and watch this X get close to 275. Look for this to be close to 275. There's 258. There's 290. So somewhere between 2.6 and 2.7. So start your table at 2.6. And now look at your table and find when this is the closest to 275. So maybe I have to go up a little. If you find you're too far off, reset your table again. Mine's annoying. Yours you can usually put your finger on it and it goes. Mine's iffy. Sometimes it goes, sometimes it doesn't. We're almost there. There we are. Here's 275 right here. See it? So it took me and I want the time, 2.556 seconds to reach that point, 275 feet away from me, and I look at my Y to see if I'm going to clear a 9-foot fence. And I will clear that 9-foot fence, don't I? I'm 95 feet up in the air, which is pretty high for a golf ball, right? Pretty high. The T-step is pretty much based on how long this is going to take you. If you're short, you want to make your T-step less than 1. If it's a long distance, make your T-step bigger. And watch what happens. If I make my T-step, say I make it 3. when I go to graph this, it's going to give me kind of jagged because this is what it's doing. 1, 2. This is not taking you very long. So it's like 1, 2. It's kind of like cutting it short. Adjust your T-step until your graph is smooth. Right? Okay. So everybody okay with this? Yes? All right. Next one. A batter hits a ball with a velocity of 92 feet per second at an angle of 55 feet from the horizontal. It angles up this way at 55. That's his angle of elevation. Find the maximum height attained and the total horizontal distance traveled by the ball. Again, it's not going to take that long to hit the ground, right? A few seconds if you think about hitting a baseball. So you want to hit this ball. You're starting at the 0, 0 again, and you're going and you're landing here. This is when and where it hits the ground. This is when your y is equal to 0. Your x value is your horizontal distance, and your time is how long it took to get there. Again, adjust your settings here. And your maximum height, I personally, I would do your when and where first. Isn't your maximum height, because this is symmetrical from the 0, isn't this exactly halfway through? So find your maximum, find your when it hits the ground. Then to find your maximum height, take that time and divide it in half. Let's take a look at this. So let's go to your thing. This is number 3. 85. Is this number 3? Am I doing the right one? No, that's number 92, right? 92. What's my angle? 55. Right, do you see the pattern here? The velocity, the time, then we have a sine of your angle that goes with your y. That makes sense to us. We turn your parabola so that it turns down, and we graph. I'm going to leave the same setup and see. Oh, I got to change my T-step. Sorry, I got to change my T-step. And that'll tell me right away. I'll even make it go smaller. What's nice about this T-step, if you could make it a little less than 0.5, because there's very, very, very few seconds, it allows you, when you do the trace, to get a little bit closer to your real value. So here's my graph. As long as I can see this thing turn, I'm fine. Now trace this. Do the trace until you get to the bottom. Hello, Mrs. Moore. Hi, good, how are you? Yes, good. Sure can. Okay, thanks. Tatiana, on the bell, can you go to attendance? Thanks. Okay, now watch. I'm going to trace. Because my T-step goes 0.3, it gets me just a little bit closer. I want to make it come down to this y. It doesn't matter that my graph looks higher. It's still going the same distance. It's just my table is my window is a little bit different. I want to see when y hits the 0. Up, I went past it. I went very far past it. So somewhere between 4.5 and probably a little closer to 4.8. So I'm going to set my table to 4.7. Just bring me a little closer to when the y is 0. I'm watching my y to be 0. Look how close we are. Right in here. So somewhere 4.711 seconds. That's going to be my answer when I hit the ground. And my horizontal distance is right here. Scroll over and come up here. If you scroll over it, you round it a little bit better to your 3 decimal places. Okay? That's your horizontal distance that it traveled. At that time. I want the time, I want the distance. Now, the height of the ball. Because your curve is symmetric and it started at the 0, once you find the time, doesn't the middle have to be halfway, right? So if my time here is 4.711, say 4.7, and I cut that in half, it's what, 2.35? So if I go to my graph and say I do a calc, because you can't do your mins and maxes on these, I should be real close. Whoops. I should be very close to the top of this thing. Now, I need you to be close, so go to your table, set it at 2.35, and go to your table. You need to see this turn. What happens is, because this is so small, you can see like it was less, then it got greater, it's getting greater, it's still increasing, that's a 4-0, increasing. You want to see it turn down. Up, right there, it started to turn down. So somewhere over here, it reached its maximum and then went back down to the 40. So I'll take any of those times. You're close enough. Because what happens is you really can't see this until you go over here. And look how close this is in here. So if you watch this and you go up one, you can kind of see I'm on my downslope. I'm still on my downslope. Somewhere in there. So I'm fine with you taking one of these, like say 2.36. Give me the time and the maximum height. Okay? I'm okay with that. Yes.
When you go to like figure out like the distance and stuff, do you use the positive number or do you go to where it goes to the negative?
You have, well, when you're figuring the hit the ground distance, I would go, the positive means it didn't hit the ground yet.
Okay, so
Slightly to the negative.
okay.
I mean, technically we should find the exact 0, we should extrapolate it, but that's more when you learn differentials, you'll figure that out. But I'm close enough going to that first little negative number. Give me the first negative, because technically, if you're still a positive, you didn't hit the ground. Ms. Fernandez and I disagree. She goes to the positive, I go to the first negative. And really, we're splitting like nanoseconds here. You're splitting a thousandth of a second. So as long as you have the concept, I'm okay on how close you get to the pieces. Okay? Now, I want to turn to, we did 5, not 4 yet. I want to go to, I want to go to a wind, but I also wanted to do all right, let's go to a baseball. When you hit a baseball, isn't it up here rather than on the floor? That'd be more of a golf swing, right? So when you hit a baseball, it's about 3 feet off the ground, right? Because if you hit it off the floor, it's more of a golf swing. So let's make this really situational here. I want you to add this. When he hits the ball is 3 feet off the ground when he goes to hit it. So now your graph is going to start here at 3 feet because that's where he should hit the ball, right? Remember when you played t-ball and you put it on the tee? The tee is like, well, at the time you were little, so like 2 feet off the ground, but not big. So probably 3 feet off the ground. And his ball is going to go like this. He's got an initial velocity. He wants to know if he's going to clear the fence when he hits the home run. You have to know when he hits the home run, which is 300 feet away from where he's standing, there's a 10-foot fence. Does it hit the fence or does it go over it to give him a home run? So we assume that gravity is the only force that's affecting the path of the ball. So we draw a sketch. It should look like this. It should have a fence here that he needs to clear that fence. Now, he hits the ball at an angle of 43 degrees. So let's set up our two pieces. So your velocity, each one of these is velocity. Your cosine and your sine, they each have an angle. And our angle we're going to use is 43. Okay. Now, your bottom, your top, let's leave these for a second. Your y has to have this because the parabola has to turn down with gravity. Gravity is working here. But what did I do with the 3 feet off the ground? Is that a vertical change or a horizontal change? Vertical. Which variable works vertical, x or y? The y. So I come down to the y, and I just start him at the 3 feet above. Add this in there. I'm adding this in. This actually is a better situation. So he can hit the ball at his hip, not on the ground. Okay? Now, we're going to set this up into your graph. So let's go put this in. We want to know if when he gets to the 300 feet, is he going to clear that fence? That's all I want to know on this. All right, so we are 103. Put it in your calculator, guys. You need to be able to do this. Okay, we got the cosine and the sine. I'm going to make this guy turn down because he's my 16, negative 16t squared. And I'm going to add 3. Better than him turning up in my class, huh? Okay, so we'll turn him down. And we'll see what he looks like. We can use the same window that we used before. Because we were still hitting the baseball before, right? Now, if you want to spread this out, be my guest. How will I make my parabola be a little flatter? Window. What should I change? I had a lot of x. Good. So I had a lot of room on that x max. So maybe I'll cut this x max down. My fence is only 300 feet away from me. So maybe I'll just cut it down to 350. We'll make it more to our situation. Now I want to know, when he hits that 300, is he going to clear that 10-foot fence? So I trace. And we come along, we trace. What is it I'm looking for? How do I know when I'm there? When x is 300, that's my horizontal distance. X is 300, keep looking for it. Up, just past it. So between 3.9 and 4.2. So let's start this guy at 4. You okay with that? Okay. Look at your table. You're looking for your x to be 300. I went a little bit past it, so I'm going to go up. I'm going to arrow up. I want to see when it hit 300. So somewhere, whoops. Okay, good. So you give me this time, when my time is 3.983 seconds, I am 300, my ball is 300 feet away. What's the vertical height of my ball? Good. My height of my ball is 28.961 feet. So did I clear the 10-foot fence with my ball? My ball is 29 feet off the ground. My fence is 10 feet off the ground. Did I make the home run? What if I had a 50-foot fence out there? Would I have made a home run? Nope. I would have made probably a double, but I would have bounced it off the wall. So this is what you're looking at, your vertical height for your 10-foot fence. Find your horizontal distance first. So your answer to me is at 3.983 seconds, His ball is vertically 300 feet away with a height of 28.961 feet. Yes, he got the home run. He cleared the fence. Aren't these great applications? Jada loves these. Oh, she loves them. Don't let her kid you. Okay, now, I'm going to change this slightly. Ready? Okay. We're going to come down here, and we're going to say, change this a little bit. Let's make, here's your X and your Y. Let's make this now at an angle of 41, and there's a wind speed blowing in the same direction. That means the wind is behind me. What should happen to my ball? Ooh, it'll be sailing, won't it? It'll sail my ball even further. If the wind speed was blowing against me, what would it do to my ball? It would hold it up. It would kind of slow it down a little bit, right? Depending on the wind. That's a pretty strong wind, 22 miles an hour. 22, actually this is 22 feet per second. So that wasn't so bad. I didn't actually ask you to convert this, did I? Alright, so get those two set up for me. Alright, so let's set this up. We have an initial velocity. What was our initial velocity? 103. 103, thank you. So they're 103. We changed your angle slightly. We brought it down a little bit so he's a little sharper. Not as much arc. We're going to use our parabola. We're going to add our 3 feet because he's going to hit it 3 feet off the ground. He's not going to golf at it. And what does the wind speed affect? The vertical or the horizontal? Horizontal. It's going to push my ball horizontally further. So if the wind is at my back, so to speak, I add my wind speed on my horizontal. But wind, look how we write this. 22 feet per second, which means I have a time here. And which variable works my time? T. So I have to say 22 T. Because my wind is also 22 feet per second. So now, let's change this in your calculator. Let's go to your Y. Let's change our angle. So we're 41. Whoops. One of these days this calculator will work nice. And we added the wind at our back here, plus 22 T. Don't forget the T. This guy, all we have to do is change the angle, leave your negative 16, leave your plus 3. Let's graph it. We still get a parabola. Look what that wind did to my ball. It took it further, didn't it? Our window was set up for 250. That wind, that's a very strong wind, 22 miles an hour. It really changed the ball, didn't it? Watch what happens if I change this wind. I'm going to change the wind to 2 miles an hour and see if that makes that much of a difference. Okay, I'm changing the wind speed to 2. Did it make that much of a difference? I'm pretty close to my window set at 350. But that 22 mile an hour wind really threw my ball. Okay, now if that wind is going against me, I'm going to subtract it. Watch what happens when I subtract the 22. Just give me a couple more minutes, guys. I just want you to see the difference. I'm going to subtract the 22 mile an hour wind. Look what it did. It held my ball up. And that's a very strong wind also. Okay, if you ever hit into the wind or threw into the wind, and the wind is against you, it kind of like holds your ball up. It looks like it's going in slow motion. Are we okay with the plus 3? Are we okay with the wind speed? Okay. Now normally wind speed is measured. That's feet per second. That was still a strong wind. Normally the wind speed is measured miles per hour. If it was 22 miles per hour, we would be in big trouble. Yes.
For these questions, the only thing I need to do is just put things in the equation?
Yes, that's all.
Oh, like
That's, you
answer?
just have to know which one's affecting which one.
Okay.
Yes. There's a quiz.